Now we'll start looking at the slope and what we can infer from our test. So first of all, in the probabilistic model, is a linear pattern we see just chance, or is there a useful relationship? You can actually roll dice and accidentally occasionally get a correlation that looks pretty good. So because there's variation in the readings, what we're assuming is that we do have a linear relationship, but we've got this sort of random variable epsilon here being added on. And so it adds on to each of our terms. Beta naught and beta 1 are population parameters, so they represent the true y-intercept and the true slope for the actual relationship. All right, and they're usually unknown since we don't normally know population parameters. Epsilon is this little random deviation that makes us go up and above and below our line. It keeps it from lining up exactly perfect. And it won't be the same for every point. And so for each given x, what you expect is that these guys are going to be kind of distributed fairly normally. They'll just be spread about that line. So the idea is, the basic assumptions are that the distribution of E at any particular x value has a mean value of 0. In other words, all the little data in the previous slide, the mean value is 0, so this average of the data is on the line, is the expectation. All right. The standard deviation of E, sigma of E, is the same for any particular value of x. So it would be, it's the spread of the distribution. The distribution is normal for any particular value of x, and the deviations are independent of each other. So let's go ahead and take a look at predicting slope. First of all, if I have less spread about the line, that S of E, then my prediction should be better, right? So the less spread I have vertically here around my line, the better the prediction. The more spread I have in the x direction, the better the prediction, all right? And that would be my standard deviation of x. And the more samples I have, the better my prediction. Which leads us to the formula for the standard error for the slope. And we're using B1, and it's standard error because we're going off the sample. All right. So here's the formula. The good news is you're really not going to end up calculating this. You'll either use standard error from a computer output, which is going to be right next to the slope, or we can actually use B and T from our calculator. All right. So let's go ahead and look at how we test slope and develop confidence intervals. First of all, when we're doing a hypothesis test, the null is that there is no correlation between the two variables, that the slope is 0. The alternate is that there is a correlation and the slope is not 0. Our test statistic looks a lot like before. It's going to be our sample slope minus our hypothesized slope divided by the standard error for the slope, okay? Then we use the student's T model, and notice our degrees of freedom is n minus 2. Don't worry, your calculator will actually automatically subtract 2. Now for the confidence interval, what we're going to expect is that it's going to be that beta 1 that we get from our sample times our t value, plus or minus your t value times your standard error, okay, for the slope. Now, one thing is when we're doing this hypothesis test, we can kind of use this to go backwards and find standard error. This is going to be 0, and if I solve this for standard error, I get this equation. So I'll use this later when you're not going to normally have to calculate it, but if you do, just remember it's the slope divided by the t value. So let's go ahead and go back to that list of data for Olympic long jump records, and we are going to do a hypothesis test. If there actually is the null is there is no association, and the alternate is that there is an association between year and long jump record. So the first thing I want to do is I have my data already entered, right? So I'm just going to go second stat and test. It's one of the very bottom tests on the list, almost there. Line reg t-test. There's list 1 and list 2. Frequency, I'm saying slope is not 0. And then go down. Oh, I can actually insert the function here. So if you did second vars, that put it in, hit calculate. And then you can see the rest of the data there. And actually, because I did that function and put in the y, if I do a plot now where it's doing a scatter plot of the data, and go back, put list 1, and then put list 2 for my X and Y, you can see that, and then I'm going to have to hit zoom. There is the scatter plot with the linear regression on it. Okay, so let's go back and look at the data there that I got. Here's the output from the line reg test. For right now, what I'm mainly interested in is this p-value. Since the p-value is so low, we reject the null. There is strong evidence of a relationship between long jump record and year. And I'm saying strong because that's pretty much 0. Normally, I will just say there's sufficient evidence, but that's pretty strong. Okay, now another thing, I want to go ahead and create a 95% confidence interval. So I'll show you how to do that one by hand. But then we're going to go ahead and do it with the calculator. So remember, I told you could actually calculate the standard error for the slope, right? It's just your b value here divided by your t. Now, I'm rounding here. This is only 2 significant digits, so my confidence interval will be a little off. So, and I can find my t interval. Now, you'll notice you're probably going, wait a second, I divided by this t, right? And I got my standard error. But now I'm trying to create a confidence interval. Well, since I'm trying to create a 95% confidence interval, I'm calculating what t should be for a 95% confidence interval, which should only be about 1.7 with 20 degrees of freedom. So it's my confidence interval is just going to be the slope plus or minus my t for that confidence interval times the standard error. All right. By the way, the sample estimate, this thing right here, the common standard deviations, or S of E, there's S of E in your output on the line reg test. All right, now let's go ahead and do this the easy way on the calculator. So it's the very last, let me go to the right thing, stat, test, and if you scroll down and go too fast, like I just did, you got to go back up. It's almost the last one, line reg t interval. There's list 1, list 2, 95%, hit calculate, and voila. There's my confidence interval up at the top for B, right there. So it's basically 0.47236 to 0.74802, and there's my slope. Very easy.